So I believe we'll start now. So good morning, everyone, and welcome once again to today's webinar titled SinoGNSS and ComNav Power Session. We are thrilled and pleased to have you here with us today. This training was organized by OTIC Surveys in mind of our clients who have some complaints being able to maximize their equipment. So that was the reason this webinar was organized. My name is Favor Hamefula, and I'll be your host for today. So today, we'll be talking about the latest innovations in SinoGNSS and ComNav technology. We'll also be discussing their unique features, and also we'll be addressing some field considerations in setting up your GNSS equipment. Also, we'll be addressing the A to Z to survey of the Survey Master app, how to efficiently use your Survey Master app. So we'll be addressing that as well. Then we'll be addressing common field issues. We'll be troubleshooting common field issues, and we'll be offering you solutions to these issues. And also we'll be talking about how to properly care for your equipment, because this is your investment. So if you don't take care of it, it will be a waste on your investment. So we'll be talking about how to properly care for your equipment. And also we'll be taking some questions from you, and you'll be getting live answers in this session. So for this session, we'll be having 3 speakers. The first speaker is the MD of OTIC Surveyor Andrew Dokai. We'll also be having Mr. Kenneth Emmanuel, and we'll also be having Edwin Ajato. So please stay tuned, write down your questions in the chat box, and be engaged, please. Whatever questions you have, whatever issue you have, don't feel shy to talk about it. Don't feel shy to note it down. So with that, I'll be calling on my MD to kickstart the first session. We'll be handling the latest innovations in SinoGNSS and ComNav technology, the field considerations in setting up your GNSS equipment. Okay, over to you, sir.
Hello.
Yes, sir, we can hear you now.
Okay. Can someone aside Favor confirm that they can hear me? If you can hear me, just type in the chat box. I can hear. Okay. Thank you very much. Okay, so we've spent enough time waiting for people to join. I think it's okay for us to proceed with today's webinar. So thank you very much for joining us today. We really appreciate you taking out time to join us. Okay, so before I start, how many of you here actually use a ComNav, SinoGNSS? How many of you here actually use SinoGNSS? Just say, you can type, I use SinoGNSS. I use SinoGNSS, or just type SinoGNSS. How many of you here actually use ComNav? Some people call it ComNav, some call it SinoGNSS. They're the same. How many of you here use SinoGNSS? Okay. Can we get more people? Okay, good. Can we get more people? Good. Okay, so let's move forward. My name is Andrew Dokai. I'm the MD of OTIC Surveys Limited, and OTIC Surveys is the Nigeria partner of ComNav technology in China. ComNav manufactures GNSS equipment and other geospatial equipment, but the primary focus is especially for this webinar is GNSS. So I've been using GNSS. I was introduced to ComNav many years ago. When the surveyor gave it to me to use on his site, and then on a pipeline project. And on that project, while we were doing it, I realized that it was much better than what I was used to. Another product, I don't want to mention the name of that product. I don't want to mention the brand. So we realized that, wow, this one performs far better. The difference is clear. So it was since that time, even though then I was serving another surveyor back then, I decided that, look, this is a very good product, and it's a product that I really want to have for my own jobs. And look, then after a few years, today now, look at us. We are not only using SinoGNSS, we are also the partner of the company that produces it. So just to give you a brief history of SinoGNSS and ComNav in Nigeria. Okay, so today we'll be talking about Survey Master app and a few other things. Survey Master is the app of ComNav technology. Is the app you use to connect to your receiver. Each brand, they have their own proprietary app. For ComNav, the app is Survey Master. It has this blue icon, as you can see on the screen here. That blue icon with a pole with a rover in its hand there. So that's Survey Master icon there. So for me, I will be taking the first 2 points in this training, the latest innovations in SinoGNSS and ComNav technology, their unique features, and then I'll also be taking field considerations in setting up GNSS equipment. Okay, so what are the latest innovations for? Okay, so for me, the latest and most important innovation now is laser. Now GNSS RTK receivers have now been integrated with laser technology, and you know that this, if you have been using GNSS, you know that this is an important, extremely important feature because of the challenge that surveyors have on site. If you have been using RTK, for us, whenever we are talking with surveyors, or for example, when we go for AGMs, when we go for exhibitions, the number one thing that people keep asking is, can you work under canopy? Can you work under canopy? Can you work under canopy? So that's the number one issue. Can you work under canopy? And what's canopy? Canopy is basically covering. When you go into a bush or forest, the trees there. So people are always like, does it have strong reception under canopy? So ComNav came up with a groundbreaking technology, laser. So now the GNSS, the receiver is now acting like an RTK and a total station together. You know that total station, when you want to measure, when you press measure on your total station, it will send a beam, a signal to the reflector, and the reflector will reflect that signal back to the station, and it's based on the distance and time and that the total station uses to calculate the distance. Sorry, it uses to calculate the distance to that object. So now laser 2 is like the same principle of total, like same principle. It sends out a signal, the signal comes back, and it measures, it uses that to measure the distance to that object. So now what this means is that the issue of canopy has, we can say, has almost ended, because if you are working in a place and you get to a point, you have been picking your point, you're doing your survey, and then you get to a point, you cannot pick a point there, you cannot pick that point because there's a covering, or it's in a forest, and that place is really covered. Because even in canopy, there are different levels of canopy. You have light covering, and then you have the very thick ones. So you have been working in a place, it's light covering, you are still getting a fixed solution, you are still doing your work, and then you get to another place and the covering there is really heavy. So when you get to that place that you can't measure, you can go back, you can shift back to where you could measure, and then use your laser to measure those points that you are not able to measure because of the heavy canopy. What this means is that you have increased productivity. It means that the need to take total session to site is as will also decrease. Even we in our own business as equipment dealers, we are seeing that the demand for total station is reducing every year. People are not buying total station like before. Everybody is buying a GNSS now. So, and now GNSS are now being integrated with laser, which means that even what total station used to do, GNSS now can do that. So, I tell you that going forward, we are going to see less and less use of total stations. The total stations will not go extinct. No, that will not happen. They are still needed in construction setting out, but the demand it has been reducing over the years, and it will continue to reduce. So with the laser, you can measure inaccessible points. Also, it's not just in the bush, also in built-up areas. In built-up areas, for example, you have a cadastral survey to do. You have the property. You start from outside the road. You measure the first two pillars in front. But on going inside, you realize that the building is a tall building. On the left is a tall building. On the right is a tall building. Even at the back, there are tall buildings. So by the time you get to the back, you can't pick your point because you are surrounded by tall buildings. That is called urban canyon, like an urban canyon, where that concept in GNSS is called urban canyon. It's like a valley in an urban area. It's like a valley for GNSS, which means that at the point where you are like in a valley. You are surrounded by tall buildings and you are at the bottom. You are surrounded by tall structures and you are at the bottom. In GNSS, it's called urban canyon. So when we still have the problem of urban canyon in GNSS, whereby you are in a place and you are surrounded by tall buildings, and then you can't get a fixed solution. So when you find yourself in this kind of situation, you use a laser. Okay, so you can see this video here. You can see this video here. Okay, so let me just allow you watch this video for a few seconds. Okay, can you see this video? Can you see what's happening? And if you understand what is happening, please say, I understand. You can see that he has to use laser to go and measure that point in between the buildings. There's a building at the back, there's this building, and there's a building on the right side. So there's satellite signal blockage. So you can see the first point, you can use tilt to tilt outside, tilt functionality to tilt away from the building and still pick that point. But the one inside is difficult. Even after using the tilt, he still cannot pick that point. So that's why he used laser. He's able to use laser. You can see he's going to the back now. Even with tilt, he can't pick the point. So he has to come out, get a fixed solution, and then use laser to pick that point. Understand? If you understand, say, I understand. If he takes his rover there, he cannot pick that point because of the satellite signals are blocked. Left and right and at the back, the left and right and back, they are buildings. So this kind of situation is called urban canyon, where you are like in a valley. You are not in a valley anyway, but it's like you are in a valley. The GNSS, the RTK, the receiver, it's like it's in a valley. Okay, so this is laser functionality because of in the past that point inside there we will have to bring out a total session to measure that point in the past, but now GNSS is able to do that. We don't need to take the rover there. We can come out and use laser to measure that point. Okay, so I think I've talked about the first one, innovation. The second one is 3D laser scanning. Now we are seeing more and more 3D laser scanning equipment coming out from manufacturers in China and all over the world. Believe it or not, 3D laser scanning will be an integral part of a surveyor's workflow going forward. 3D scanning will be an integral part of a surveyor's workflow going forward. With 3D scanning, you can go to a site and capture everything about that site. Everything, because the scanner captures hundreds of thousands of points per second. And then because it can be integrated with an RTK receiver, you can see at his back there, he has an RTK receiver at the top. At the top there, you can see there. So because it's integrated with an RTK receiver, you can get very high accuracy, sometimes even millimeter, 1 cm, 1 point something cm, can get very high accuracy. So in the future, what we are going to see scanners integrated with RTK. That's how they will come, not as separate entities. You can see this one now, they are separate entities. The receiver is on top, and then the scanner is at the bottom. In the near future, I'm telling you, within the next 2 years, it will be natural for receivers to come with 3D scanners integrated, and then also you'll be able to put the device, the two of them together on a pole, so that you can do normal, if it's just cadastral survey, anything, any kind of survey, you just do it normally because the receiver has a scanner integrated into it. And whether you need to use it or not is there. Whenever you need to use it, you switch to it, and then you can just put it on a pole and do your work like a normal RTK receiver. So abroad, 3D scanning is commonplace. It's everywhere abroad. So and you know that you should know that within a few years it will be commonplace in Nigeria. You are going to see 3D scanning everywhere in a few years. So I think those are the two main latest innovations that we need to look at and understand going forward. We need to my colleagues, we talk about call station, which is not really an innovation, but which has become more and more popular within the last few years in Nigeria. So they will talk about that one. But for real innovation, the laser and the 3D scanner are the most important innovations that we think you should know about now. Okay. So I'll go to the second point, which is field consideration in setting up GNSS equipment. Field considerations in setting up your GNSS equipment. So I'm just going to talk about. I'm just going to touch on 2 points. But before I do that, we know that GNSS means Global Navigation Satellite System. We know that GNSS means Global Navigation Satellite System. If you know, type I know. I know. If you know, type I know. GNSS means Global Navigation Satellite System. If you type I know, okay, good. Any other person? I know. Okay, good. So now in the beginning, people used to say GPS, but GPS is just one of the satellite constellations that is in space. So in the beginning, we had only GPS. GPS is owned by the United States of America. But after some time, we now had GLONASS, which is owned by Russia. And then we now had Galileo, and then we now had Beidou and Galileo. So you can't call it GPS again, because almost every device comes with all these constellations. You can work with them. They work together to give you coordinates. So we can't call it GPS again. So they now decided to change it from just GPS to Global Navigation Satellite System. Now, like I said, GPS belongs to America, GLONASS belongs to Russia, Galileo belongs to Europe, and then Beidou belongs to China. These ones are Global Navigation Satellite System, but we also have regional navigation satellite system like IRNSS belongs to India, QZSS, which belongs to Japan. Those ones you can't get their signal everywhere in the world. Although for India, we are beginning, our SinoGNSS is beginning to track India. We are seeing when we check the satellites that are tracked by our equipment, we are seeing IRNSS like 2 satellites. So I think over to capture more of the IRNSS satellites. But QZSS, the Japanese, we've never seen before. So the regional satellites, maybe with time they will expand, and then we may be able to get those signals from QZSS. You know, initially when Beidou came out, it was just China, and later it was I think when Beidou 3 came out, then everybody now became available to the whole world. So that's for that. Now, when you are setting up your GNSS equipment, I tell you the most important thing is your base location. When you are doing base and rover survey, the most important thing is your base location. Can somebody type base location? Base location. What I mean by base location is where you put your base. The place where you put your base is the most important thing. The place where you put your base is the most important, because it determines every other thing. Can somebody type base location? Base location. The location of your base. The location of your base is extremely important. It's extremely important. It determines the quality of signal that your rover will receive. It determines the quality of signal that your rover will receive. Your base location determines the quality of signal your rover will receive. And in order to explain this, I will just tell you a simple story which will drive this home. A few years ago, when we bought a new GNSS that could track more satellites and was advanced compared to the one we have been using, we took it to a site and we set it up in Lekki. We had this a site, a compound in Lekki, Lagos, for those that know Lagos. And it was around the Orchard. So we set the base inside the compound, and it's a built-up area, and the property has a building. So we set the base in the compound, and we now set out to start measuring. And then we realized we couldn't measure any points. Almost everywhere, aside the points outside, we couldn't measure even the points outside. We were having challenges measuring the points. So what's happening? We are very close to the site. Why are we getting floats? How is this still not? How are we getting float solution? We checked everything. Everything looks okay, but we are getting float. So it now occurred to me that maybe these buildings this base is too close to the building. So we now took that base outside, not onto the street. We took it outside the street completely, close to the road. We took it away because that place is a built-up area. So there are buildings everywhere. We now took that base outside, close to the road. You will not believe we were able to pick all the points. We came back to the site and picked all the points easily. Despite the fact that the base was now farther away from the rover, farther away from the site, we took the rover to the site and picked all the points easily. Picked everything easily. The building, the boundary points, we picked everything easily. So that was a learning, a place. It was something that we learned at that time. That look, the most important factor for setting up GNSS is your base location, because the base was now in a location where it could the signals could propagate properly. The signals could propagate properly and spread out wide. We were able to. That's extremely important for the base. We were able to measure do our survey well and just finish our work on time and leave the site. So for you going forward, when you are going to site and you want to do a survey job, make sure that you put your base away from tall buildings. Put your base away put it in an open area, and then make sure that there's somebody with the base all the time. Make sure that there's somebody with the base all the time. Don't leave your base alone, unattended to. Somebody must always be with your base. Somebody must always be with your base. Don't forget this, because it may be a sorry situation. You may be surprised when you come back. Please, I tell you, we have had surveyor that he left his base alone in the bush, and when they came back, when he got back there, the base was no longer there. So please make sure. I've talked about one, base location. Second, maybe I'll call the other one, this other point, security. Make sure that there's always someone with the base. Aside from somebody even trying to steal it, somebody may push it down. Somebody may just adjust it that he wants to pass. You just move it. So, which is something you don't want. So, please, first thing, set up your base in a good location, open, and then second thing, make sure that there's somebody with your base. Okay. Then there's the last one is, should you set up on a control or not? Should you set up on a control station or not? So, with modern GNSS, sometimes with modern GNSS, you don't really need to set up on a control. Yeah, you can just do what we call site calibration, whereby you just set up your base anywhere, and you can put the rover on the control point, and calibrate on that one and go ahead and do your work. You can do that. Even some equipment brands now, when they sell equipment to you, when they sell it, they will not even give you tri-brack and spindle. Your tri-brack that you need to set your base on, they will not give it to you. They will just give you a plate. So sometimes you see some people they will set their tripod and you set, and then their receiver on it with 30 centimeter pole, no tri-brack and spindle. So without the spindle and tri-brack, you cannot center over a point. So some brands we actually force people not to set up on a control. But I just want to let you know that it is good to set up on a control. At least, even if you are not doing it, at least know how to do it, because you may go to a site, and when you get there, the engineer there, the supervisor will say, "This is our control point, and I want you to set up your equipment on it. Don't do any site calibration here." So please, if you are working somewhere, wherever you are working, learn how to set up your base on a control. Learn how to set up your base on a control. It's not old school. Yes, that's how we started, and there are new methods where you don't need to do that, but it's not old school. Don't let anybody tell you that that's old school method. It's not old school. Learn how to set your base on a control. You can never tell your situation you will meet at the site you are going for. When you go there now, you meet the Indian man or the Lebanese man or even the Nigerian, and they will tell you, no, we don't do that here. Set up. Or for example, if you are working in the oil and gas industry for a company like Shell, they already have their own base stations. You can't tell them that you want to do site calibration. It's not possible. I will even give you an example now before I close. I think that's the last thing. We have a client in Port Harcourt that bought another brand, and it's an oil and gas work. I think it's for Shell. I can't remember. And then his equipment could not pass the calibration test of the company. It could not pass. So somebody now told him, what happened now? Why didn't you go and get SinoGNSS? We have used it for many of these kind of jobs. So the guy had to come and buy Sino, even though he had paid money to another company for another brand. So because that brand, my own idea is that brand, they usually force people to do site calibration and not actually set up your equipment on a control point. So please take note. Take note, it's very important. If you are buying any equipment, we recommend, definitely recommend SinoGNSS, but if you want to buy something else, make sure that you need to ask, can I set it on a control? Not site calibration, not using my rover to calibrate. Can I set up on a control? That's one important question you need to ask before you buy. Okay, so I'm done. If you learned anything, please say I learned something, or just type yes. If you learned anything new, can you type yes? If you learned anything new, can you type yes? Okay, thank you very much. So just to do a short recap, not a total recap, just like I said, people, whenever we are talking to somebody that wants to buy equipment, they always can it work under canopy? With laser, we have Jupiter laser and we have Mars laser. The issue of canopy has ended with SinoGNSS. So if you are talking to your friends and they are talking about canopy, just tell them canopy is a thing of the past. Issue of with laser now, you will solve maybe at least 90 to 95% of your canopy issues. You are going to solve. So it's an innovation that has come to stay. It's an innovation that is increasing productivity for surveyors, and it's an innovation that you need to pay attention to. So the other one too is 3D laser scanning, which I talked about. You need to begin to pay attention to 3D laser scanning. It has come to stay. It has come to stay. Base setup in an open area always, and then make sure you don't leave your base alone. Make sure you don't leave your base alone, so that you will never walk alone. For those of you that watch football, you know you will never walk alone. So please make sure that you don't leave your base alone, so that we will avoid stories that touch. Okay, somebody is saying something about PPP mode. Well, that one too is an innovation, but let me tell you the truth about PPP. Thank God you brought it up. I don't know if any of my colleagues plan to bring it up, but thank God you brought it up, and I have to close now. You see, PPP is a technology that is still in its infancy. It's still young. It's not mature yet. Even though there's a brand, there's a company that's going about claiming that they have 1 centimeter accuracy, 5 centimeter, claiming very high accuracy on their PPP. It's not true. It's not true. We will never do sensational marketing. There's something called sensational marketing, whereby you say your equipment can do something it cannot do. We don't do that, because whichever way the customer will find out. So PPP is still in its infancy. PPP means precise point positioning. It means that you don't need any core station, any base station. You can get centimeter accuracy anywhere in the world. Anywhere in the world, you can have only a rover without internet connection, nothing, just a rover and your data logger, and you can get fixed solution. But you see, to get that fixed solution, you need to wait for minutes. Sometimes 20 minutes, 25 minutes to get. Now, some brands within 3 minutes, 5 minutes, you get fixed solution. But we have compared different brands that do PPP. We realize that those ones that get fixed within 3 to 5 minutes, the accuracy is really poor until after like 20-something minutes. When we compared the two brands, our own with another brand that gets fixed very fast. When we looked at it, we said, why so fast? So, okay, good, let's check. Whereas, although the thing fixed early, but before it became accurate compared to our ground controls and compared to the other one, we realized that it took 20-something minutes. So So some brands will make you think that you've gotten fixed, you've gotten good values, you've not gotten good values until 20 something minutes. So for now, that's the limitation of PPP. And usually your accuracy will be between 10 cm. You may be lucky to get less than 10 cm, but it's around 10 cm to 30, 40 cm. It's not the 3 cm or the 1 cm that some brands are claiming now. It's not. So that's what you need to know about PPP. For now, it's still, I think maybe by next year, next 2 years, yeah, we will see more of PPP. But for now, that technology is still in its infancy. It's not that accurate yet. You can't compare 10 cm to 40 cm to millimeter and 1 cm that you can get with RTK. Also, the stability is not that stable. PPP, by the time you enter any small bush, it will go off, it will go to float. Any small obstruction, any little obstruction, it will go to float. It's not stable. So you can't really depend on that one. So the only time that we see that once in a while that somebody uses PPP is when you go to a place where there's no network, there's nothing. Because now we have call stations all over. We have call stations in several states, and I hope that Favor will also tell you about our call stations and the other instructors. We have call stations, but there are some places you go to that there's no call station, there's no network. It's only in those cases that you can use PPP. But you should also know that your accuracy will not be high. Your accuracy will not be high compared to using RTK. But in those cases too, you can also log static. You can do static. If you know how to do static, you can do static or you can do base and rover. Place where there is no network. So when there's no network, you can do base and rover. You can also log static data for post-processing data. So I think I've explained PPP well, and if you have any questions, you can let me know. Thank you.
Thank you so much, sir. We appreciate the insights. Thank you for breaking down PPP for us and opening our eyes to the truth about PPP mode. We are really grateful. So if you learned something, I want to see your comment in the chat box. If you learned something in this session, type new in the chat box. Okay, thank you. So while we'll be going to the next section, which is about Survey Master app. So we are going to be mastering our Survey Master, which is the custom app for SinoGNSS equipment. So we are going to be showing you how to efficiently use your Survey Master app. But before then, if you've seen this flyer on our social media handles, say I've seen it on the chat box. If you've seen this flyer, the 360 surveillance training flyer on our social media handles, say yes. Type yes on the chat box. If you've seen this flyer on our social media handles, type yes on the chat box. Okay. Kehinde has seen it. Kiwande has seen it. Adisa has seen it. Who else? Oh, good. So OTIC Survey is in collaboration with Josotech, having a 360 surveyor training, just as it is in the flyer. So we'll be training you on the use of total station, level, and GNSS equipment. My boss mentioned control setup, how to log static data for control establishment. So these are one of the things we discussed. Okay, so we'll be moving on to the next session, which is survey session. So I'm calling on my colleague, Ajato. He will be handling the session. So please, I can see questions in the chat box. So please be patient. At the end of the webinar, the questions will be attended to. So please note your questions. You can put them down in the Q&A session, the question and answer session. You can put them down there, or you can put them down in the chat box. We'll answer all your questions. So over to you, Edwin.
Okay. If you can hear me, just signify by saying I can hear you, or just type something. Okay. Thank you very much. Wow, you can't hear me. Okay. All right. So, good morning. My name is Edwin, and I'll be taking you on the next session, which is we'll be talking about the the Survey Master application and everything you can do with the Survey Master application, starting from what the application is, setting up, doing up, configuring your permanent settings and your temporary settings, how to do setting out, and how to export your jobs, how to set up your work mode. So these are all the things we'll be doing on this section. So please we stay with us and make sure you pay attention. So let's proceed. First off, I want to start sharing my screen. So just signify when you see my Survey Master application. So hold on. Okay, so I'm currently on the project page. So I'm switching to device and survey and tools. Please let me know if the switching is happening on your end. Okay. All right, so we want to proceed. So the first thing we are going to be talking about the Survey Master application is that we all know that most of these equipment that we see on the market, not only from SinoGNSS, from other brands, they have their applications that work with the equipment. There are some applications that are not specific to a brand. There are some that are specific. Like if you know of this SOPAD application. SOPAD application works for different types of GNSS receivers. So, but there are some that are limited, that are specific for a specific brand. So SinoGNSS is a GNSS application, is a professional surveying software that works with the SinoGNSS receivers, which is also the ComNav receiver. So what we are going to be doing is we are just going to go run through everything that you can do with the application. So first of all, we are going to properly talk about setting up the equipment, like setting up your Survey Master. So as you're setting up your Survey Master, you're also setting up your equipment. So we'll be talking about setting up your Survey Master. Now, if you are setting up your Survey Master, there are two types of setup that you will be doing. Now, there is one that I like to call the one-time setup. So I call it one-time setup because it's something that you just do once, and that is what you don't need to do it again. So it's just like setting up how if you get a new phone, you set up how you want your home screen to look like, you set up how you want your incoming calls, incoming calls, a ringtone to sound like. So those setup, they are one-time setup. So you just do them once, and that is what you'll be using as you are using the equipment. And then apart from the one-time setup, we have the reoccurring setup. So those reoccurring setups are the kind of settings you'll be doing anytime you go to site. So let's say I've gone to site today, I came back. When I'm going to another site tomorrow, I will need to redo some of those settings. So those ones are the reoccurring setup that we'll be doing. So first off, we are going to talk about the one-time setup. So sorry, before we continue, we have a question from Mr. Okoyemi. He says, please, what is the name of the application that works for most GNSS again? So like I mentioned, there are some that works for specific receivers, that specific brand. There are some that you can use for various different types of brand. The one I mentioned was SOPAD. I'm typing it on the chat so you can see it. It is SOPAD. So this application works with different equipment. It works with just more than one brand. So you can use it. You can even try it with your ComNav, but I doubt if it will work. But then it's a survey application that works for different GNSS receivers. So we are going to proceed now. So back to our Survey Master. Now for your one-time setup. These are the setup that you just need to do only once, and then you don't need to do them again. So for those setup, what you do is, see, we are currently on our project page. If we change to the second page, we have device. The third page is where we do all our surveying, like topo survey, laser resection, point stake, cat stake, PV stake, line stake, and so on and so forth. And then the fourth page is where we carry out measurements, calculations based on the data that we have. So you can do card alignment, you can do area calculations, you can do earthwork calculations, you can do COGO, which is a coordinate geometry, that is like calculating distances and offsets, and so on and so forth. So for the setup, you have to do just one time. You come back to your project page. Now on your project page, you will see settings. Now also, there are some survey master applications that's they are older. This is a recent version. This version number is version 4.0.2. There are other versions that have been released before this one. So depending on how your own version is, you can see these settings inside this more. But for this version, the settings is already on the project page. So we just click on our settings. Now, when you click on settings, the first thing you see there is units and decimal. So this is where you set up your units. So for your length measurement and your distance measurement, you can use meters, you can use international feet, you can use US survey feet. So, but for the standard in Nigeria is that we do our distance measurements with meter. So you select your meter as your settings. And then for decimals, this is where you set, after your decimal, how many values do you want to have. So naturally we have it at 3 values after our decimal. So you can set it to 4, you can set it to 2, you can set it to 1, depending on what you want. So we are still going to stick with the 3 decimal places. So that is what we have. For our angles, we have distances, we have degrees, minutes, and then we have the seconds. Also, apart from this format, we have just degrees, we have just degree, minutes, and then seconds in decimals. We have gradients, but in surveying, what we use is the degrees, minutes, and then the seconds in decimals. So we are going to select that, and then we'll move forward. Next is our decimals for the angle. So after the second, in degree, minutes, and seconds, you have your decimal on the second part. So after your first and second value, you now have your decimal point. So how many decimal places are you referencing to after the decimal point is what you set here. So we are still using 3 decimal places, and so on and so forth. If you are setting your this thing for lat long, how you want your lat long to be displayed, you can also see it here. I think we selected the wrong option here. This is supposed to be degrees, minutes, and seconds, not column. So it's the same thing we have here on our lat long, and then the same thing for our area measurements. Our area measurements are referenced to square meters. So if you want to reference to square kilometers, square feet, or square feet US, acres, hectares, or and so on, you can just select the units you want to use. But generally in surveying in Nigeria, we use square meters. So we are selecting square meters. Also, for earthwork calculation, we do earthwork calculations to cubic meters. That's meters cube. So that's what we've selected here. And select also to cubic kilometers. You can select also to cubic feet. For survey master and for surveying in Nigeria, surveyors in Nigeria, we use cubic meters. So those are the setup for units and decimal places for our survey master application. Next is you set up your coordinate order. Now for most people using Survey Master, you find out that when you export your jobs, you see that nothing comes before instance. But when you want to plot your job on AutoCAD, you will naturally use instance before before nothing. So you can do that setup here on coordinate order. So now we're showing us nothings before instance. You just need to change to instance nothings, and then your coordinate order will be the way you want to see it. And then after coordinate order, we have our survey. Now for this survey, we need to create a project. So we'll quickly rush and create a project before we come back to that. So go back to our project page and click on projects and click on new. So we'll quickly type in the name of our project as a Survey Master Test. So this is going to be the name of our project. Naturally, if you are creating your project, you still need to attach the coordinate system that you are using for that project. So to do that, you come to Datum and then you click on Datum Store. From here, if you want to use your default parameters, you can select default parameters. If you want to select your coordinate system from your coordinate system store, which is also your Datum Store, you can do that by just clicking on Datum Store. Also, if you have a coordinate system on another data logger or another place that you can just scan the QR code, you can do that as well. But for here, for now, we'll just use our Datum Store and then select our coordinate system from our Datum Store and then click on OK. Click on OK, and then we'll now create this job using that coordinate system that we've selected. So our job has been created. Next is we are going back to our settings again. So back to settings and then survey. So before you can do any setup on survey, like we said, you need to create a job that you're working on. Now, the settings you do on survey basically is how you want your topo survey to look like, or how you want the points that it's just basically on how you are doing your survey. So whether you are acquiring data which is on topo survey, or you are doing setting out, road stake, PPK, card, everything, you do them here on settings. Also, you can also access this settings page from the topo survey page. So we'll see get to that later, but let's just do the setup from here first. So we are going back again to survey. Now on the first page, which is the survey page, is what you set up how you want your topo survey to be like. Now if you check, the first thing we have is our survey method. So for topo survey, here you are acquiring XYZ data. Precision is very, very important. So precision in terms of how accurate you want the coordinates that you are getting to be. Now, if you are connecting your base and your rover, precision is determined based on your network strength or your distance from the base station, or even sometimes the satellites, the amount of satellites you are tracking. Now, all these are kind of factors that will affect the precision that you are getting. So when your precision is low, it means you'll be getting high values, high error. But when your precision is high, you will be getting low value. So this setup helps you to measure the amount of the accuracy you are getting on that point you want to pick. So if you check, this is the first one we have is the HRMS, which is the level of error in the horizontal, and then the level of error on the vertical. Now, if you check on the HRMS, we have 0.020 meters, which is 2 cm. Now, what this means is that if you are trying to pick a point and the error at that point is above 0.2, it will flag off the accuracy alarm, telling you that the accuracy you have does not meet what you set. So at that point, you cannot do any survey. So what you need to do is to adjust your accuracy. Sometimes most of the times you'll be getting something with less than 2 centimeters, but in the case whereby sometimes you are far from your base station, or you are having satellite obstructions, or probably your network strength is not good enough, your accuracy will be dropping. So if it goes above this 2 cm that you set here, it means you cannot solve it at that point. So basically, what you set here will determine the accuracy that you want to be getting while you are working on site. So we advise most times that you set this accuracy to, you can set it to 5 cm or even set it to 0.1. And also on the vertical, you can set as well to 0.1. And then that will be what you'll be using. So anytime you are probably you are far from your base station, and then your accuracy is not as low as it's supposed to be, you can still pick your points, because anything below 1 centimeter is still a good enough accuracy. So this one will allow you to still work and still make sure you are getting accurate data. So the next thing is, you see under it we have fixed. Now that it is fixed, it is on. The fixed is on. It means it will be checking your accuracy anytime you want to pick points. But if you turn it off, it means it's not going to be checking your accuracy again. So it will just pick any point, whether the error there is 5 meters, whether the error there is 2 meters, whether the error there is 1 centimeter or even 5 mm. It will not check. It does not care. It will just pick your point the way you want it. But if you want the equipment to be checking your accuracy for you, you need to turn on the fixed. So that is what you need to do. So now you can see it's off and the accuracy bar has gone off, meaning it's not making use of the accuracy check again. So you have to keep it on at all times to keep your accuracy under check. The next thing we are going to talk about is your point step size. So this is just basically the size of the point. When you pick a point on your survey master, the size of the point it will be showing on your topo survey page. So you can set it to any size you want. And then the next is your occupation time. Occupation time is the time it will take for it to do all the calculations it needs to do and give you a coordinate or that point you want to survey. So if you set it to 5 seconds, when you click on survey, it will do those calculations for 5 seconds and then it will give you one particular coordinate. If you set it to 10 seconds, when you click on survey, it will be doing the calculations for 10 seconds, and then after that it will give you the coordinates. So you can set it depending on the time you have or depending on how accurate you want your points to be. So now it's on 5 seconds. You can set it to as low as 1 second. You can set it to as high as 60 seconds. So 60 seconds is the maximum and then 1 second is the minimum. So next is your offset radius. That's already at 0.5. So we'll leave that at 0.5. Next thing we are going to talk about is the ones that are important that we are going to talk about is duplicate name. So you see now duplicate name is on. It means when you are picking your points on topo survey, you can have P1 more than one time. So if you turn off duplicate name, anytime you have P1 and you want to pick another point that is named as P1, it will not allow you to save that point. So duplicate name, now that it is on, will allow you to pick a point with a particular point ID more than once. If it's not on, you can only pick one point, you can only register a point with one point ID only once. So you need to take note of that. Also, PPK is kind of a setup you do if you are trying to do post-processing. It's almost like doing static processing, but with a shorter time. So PPK is also there. Now, for the second page, we have our stake. Now, on stake, you determine how you want to setting out of points. You determine how you want to do your setting out of points. So we have high stake alarm, medium stake alarm, and low stake alarm. So low stake alarm is kind of the the alarm you get when you are getting closer to the point, but not very close. So if you see the low stake alarm starts from 1 meter, so if you are 1 meter around the point, it will start telling you you are close to the point. Now, when you get to 0.5 meters around that same point you are looking for, the alarm intensity will increase. That is the medium stake alarm. And then when you get to 0.505 meters around the point you are looking for, the alarm intensity again will increase. That is the high stake alarm. So you can set up, you can do this setup to any way you want. So basically what we normally use is 0.2 for the low, then we use 0.1 for the medium, and then 0.2 for the high. And then this will help you do your staking out more accurately. And then this is basically what you need to set up for staking alarm. And then finally, there's road, there's PPK, there's card, but we won't be talking about that. The last one we'll be talking about is information. Now, if you check on your topo survey page, information are those data that you'll be seeing under the screen. So if you check, you'll be seeing your nothings coordinates. If you check, we have other options and we have selected options. Now, on the selected option side, we have our nothings coordinates, we have our distance to the base station, we have our eastern coordinates, and then we have distance of change it to the, which is the distance from where you are going to the point you picked last, and then the Z coordinate. Now, apart from these 5 that are already here, if you want to be seeing your, let's say you want to add distance to change in height, you can click on change in height and then click on the arrow. It will come to the other side. If you don't need it anymore, let's say you don't want to be seeing your change in 2D, you can select change in 2D on this side and then click on the other arrow. It will come back, it will go back to the previous page. So this is how to select the information that you'll be seeing on your topo survey page. So that is for, that's basically what you'll be doing for your one-time setup. So now we'll be going, all the other setup they are not necessary, but let's just run through them. So we have display settings. These are your survey point or your topo survey. This is the color, and then the size as well, the icon and the color, everything. You can make adjustments based on how you want them. Also, we have a keyboard shortcut. So if you want your volume up button to carry out a particular function for you, you need to set that. See, now it is empty. Also, you can also set your screen orientation. Now it's on vertical, so you can put it on horizontal, and also you can put it on automatic. Then we have our interface. This is just to set up how your Survey Master application looks like, and then your language. So these are what you'll be doing basically on the one time, which is the permanent setup. Now, after the permanent setup, what you'll be doing again are the temporary setup. Now, on those temporary setup is where you create your projects, set your coordinate system, set up your work mode. Now, if you want to create a project, you come to the project page and click on project, and this is where you create your project. If you want to set your coordinate system, everything about coordinate system is on Datum. On some equipment, you will see it as coordinate system, but on the Survey Master application, it is labeled as Datum. So if you want to create a new coordinate system, you need to enter these parameters, and then you click on OK. And then finally, setting up your base and your rover. So which is your work mode. Work mode basically means how your receiver communicates. Now you have your base, you have your rover, and even sometimes you have a call station. Now, when you are going to site and you go with a base and a rover, you need to first of all set up how the base will communicate with the rover before you now set up how the rover will communicate with the base. So let's just quickly go through this reoccurring setup that you do. So first off is to create a project. like you see, we've already created a project where we started. So we'll just quickly do that again. So when you come to project page, you click on projects and then you click on new. So you will need to type in the name of the project. So let's say we are using another test as the name of the project. From here, you select your coordinate system from your Datum store. And then when you click on OK, you have created your project. Now, one thing you need to know is that it is that particular project that you are working on that will be showing at the top of your screen. If you see now, test is showing. So if you come back to our project page, and maybe we want to go back to Survey Master test, we just slide to the right and click on open. This green icon is the open. See, it has gone back to Survey Master test. So that is how to switch from one project to another one. Now, another reoccurring setup, although it's something that you need to set up once, and henceforth you just need to select the one you are using, is the coordinate system. Now, if you come to that one, this is the coordinate system that we are using already, the parameters for this particular job that we've created. Now, if you come to common coordinate system, which is on the top right corner, you will see we already have one coordinate system on our store. Now, if you want to create new coordinate system, probably your UTM coordinate system, your WGS coordinate system, and maybe your NNO, which is your west or mid belt or east belt coordinate system, you come to more, and then you click on add from predefined. Predefined means you are adding from the custom coordinates that came with the survey master. And when you click on add from predefined, you change your country, which is your region, from China. So we are changing it to Nigeria, which is where we are currently at. Although you can also select based on the country that you are. So for Nigeria, we will select, we already have UTM zone 1 there, so you can add zone 2, zone 32 and zone 33. See, zone 32 has added to the list. Also, we can come back again, redefine, change our country to Nigeria again. Nigeria, and then we now select 33. So see, we now have zone the UTM 31, 32, and 33 on our coordinate store. Now, if you want to customize your own coordinate system, like for example, in Lagos State, we have a customized coordinate system, and if you want to do something like that, if you want to do something like that, you come to more. This time we are not using add from predefined, you are using customize. So we click on customize. Here, we will now type in the name of the coordinate system. So for Lagos State, we are using Lagos Vector 4 coordinate system. So we've typed in the name of the coordinate system. Our source is always on WGS 84. The next thing we are going to select is our target ellipsoid. So for WGS, for Lagos State, our ellipsoid is a Clark 1880. So this is Clark 1880. We select it and then we click on OK. The next thing we are doing is to select our projection. So on our projection, we'll click and select UTM. So our coordinate system is still on UTM. And then our zone is on zone 31. So with that, we'll click on OK. And then the final, although not the final thing, the next thing we are doing is to set up the transformation parameters. So this is where you now enter those 7 parameters you have for we use here in our coordinate system in Lagos State. So I'm quickly going to enter them so that we'll see how it looks like. So for DZ, which is the change in the delta is 180.472 174. For DY, the coordinate is the 98.214.179. And then for DZ, we have minus 113.210457. And then for RZ, which is the rotation on the x-axis, we have minus 4.9440 624 474056. Oh, can't go more than that. Oh, 944 062 474 056. Okay. For RY, it is minus 0.021137131683. For RZ, it is minus 0.4666327. And then the scale is minus 962 795 346535. So we've entered the complete 7 parameters for our vector 4 coordinate system. We'll click on OK. Now, vector 4 uses a droid model, which is a file that is already on the survey master. You just need to go and activate it. So this is it, EGM96. So select it and then click on OK. So once we click on OK, we've created our custom coordinates system. Another coordinate system we will also want to create is your WGS coordinate system. So when we come to more, click on customize again. So we enter the name as WGS 84. Can use zone 31 as well. Now for this coordinate system, our target is still going to be WGS, not Clark 1880 this time. So this is WGS 84. Click on OK. And then we'll now select our zone, our projection zone, which is still UTM zone 31. Okay. And then we still select our droid model. And then click on OK. We've customized our WGS zone, WGS coordinate system. So you can also customize this based on your own zone. So if you are in zone 32 or zone 33, you will select zone 32 or zone 33. So this is how to customize your coordinate system on the Survey Master application. Another thing is how to set up your work mode. So on setting up your work mode, you need to first of all connect to the receiver. So everything about connection and setting up of receiver is done on the device page. So we are going to the second page. First off, we want to connect to our receiver. So we are connecting to our N3 receiver. So once we select the receiver number, is connected. The next thing we are going to do now is to set up our work mode. Now, if you are working with your base and your rover, you first of all set up your base and then disconnect from the base before you set up the rover. So when you come to base, so these are the follow come work mode that comes with your survey master. You cannot delete it, and also you cannot edit it. So we basically do not make use of it. So what we just do is we create a new work mode. And when you're creating a new work mode, you now select the mode of communication between the base and the rover. Now they have several mode of communication, which is the data link. Now, for some of our GNSS receiver, it has SIM card slot where you can put SIM card. So if you are using that SIM card slot, you select internal GSM, which is the first option, and then your correction will be sent from your base to your receiver through the internet. Another bulk mode is internal radio. So the receiver has where you can insert a RIP antenna. So it will be sending that correction from your base to your rover through the radio mode and the radio frequency that you will set up when you select radio mode. And also, if you want to go longer distances with your radio, you need to set up an external radio device. So if you are doing that, you select external radio. So for now, let's just use internal radio to do the setup. Now, when you select internal radio, you are going to select the protocol. The protocol means the kind of command it will be sending, or kind of the data it will be sending from the base. So if your base is sending corrections using the SN long link format, you also need to receive it from your rover with this same format. So once you set up your protocol for the base, you also set up the protocol for the rover. So now we are going to use the transparent, which most people are familiar with. And then the power means the amount of battery or the amount of power it is taking to power the radio device. So we have 0.5, 1.0, and then 2.0. So 2.0 is the highest, meaning it will function at maximum capacity. So we select 2.0. And then the channel is just as setting up your walkie-talkie channel. So if you are not on the same channel, you can't communicate. So it's the same setup you are doing on the base, it's the same thing you are doing on the rover. So we'll still stick with channel 6. So you see all the setup we did here, we will click on confirm. And then the most important one is that you need to set up your start mode. So for when you're setting up on the control, like my boss said, there are equipment that will allow you set up on the control, and there are some that you need to do calibration with your rover. So if you want to set up on your control, you select fixed position on your start mode. But if you want to calibrate with your rover, you select auto base. So when you select this work mode and then you click on save, it will now ask you to type in the name you want to save it. So we'll just save this as internal radio and then we'll click on OK. So this is the work mode that we've created now on our base. So once we click on it, we just select start. Some survey versions will show you it's still the same thing. So just select the work mode you are using and click on either start or apply, and then it will start configuring your base station. Now, if you check, the one we used is auto base, so we did not enter any coordinate of the base station, but we want to go back again and do the one for the fix. So instead of clicking yes to disconnect, I'll click on no and go back again to that my base setup, and then modify this setup. So I want to change that auto base. I'm changing it to fix. Then I'll click on save. Now, if I click on start, it will now ask me to enter the coordinate of the base station. So this is where I will now enter my point ID, which is the name of the control. Sometimes our control pointer, this is SXT or whatever the name of your control is. So we are going to use a OTS. Using OTS1 as our point ID for our eastern coordinates. Let's click on receive to generate coordinate for our base. So we'll just quickly correct these coordinates: 6.5, 5.332. This is 0.4426. and then the height is 2.854. Now we also need to measure the height of the receiver from the control point to the center of the receiver on the side. So to do that, to select slant, and then we enter the measured height. Our measured height is 1.765. That means that we now click on OK. So for the base station using these coordinates that we've entered. See, we finished setting up our base station using that control coordinate. So once we click on yes, and then we've disconnected from the base, next thing we'll do is to select our rover and then we'll connect to. So we are still going to use this same receiver for our rover setup. So let's, now that we finished our setup, the next thing we have to do is to come to, and then come to new, do the same setup you did on the base. So we are using the same internal radio and the same protocol, which is transparent, and the same channel 6. We click on confirm, and then we save this as internal radio, and then we click on start or apply. So once you do this, your GNSS should fix immediately after it has finished applying the work mode. So your GNSS will fix immediately. Our own will not fix now because we did not set up a base. We are using the same receiver for base and rover setup. So now there's no base, only rover. So another thing we want to do is to set up this our rover now connecting to a call station. So we'll go to rover, click on new. We already have our radio work mode there already. So we'll click on new again, and then this time we are not using radio again or GSM. We don't have SIM card inside our receiver, but we have network on our data logger. So we are using PDA course this time, and now we are selecting call station because we are connecting to a course base. Now when you do that, you will now enter the IP address of the base station, which is 207.180.233.207. That's the IP address for our base station. The port number is 2070. The username is OTIC, all small letters, and then the password, username OTIC. The password is also OTIC. Now, when you enter these details, you will now come to source list. On the source list, you will see the download button by the far right. You click on the download button to generate the list of base stations that are on that server. So we have OTIC Osgov, which is our call station in Abuja. We have OTIC OSSG Oshogbo. This is the call station in the sub-regional office in Oshogbo. We have OTIC Onitsha, OTIC Uyo, OTIC Auchi, OTIC Akure, NIS Iwo, OTIC Yanegwa, OTIC Oyo. This is in School of Service, and then we also have NIS Oshogbo. We have Enugu, and then we have Benin. So depending on your location and the call station that is close to you is the one that you will select from this list. So we'll quickly just select, think we can connect to, let's select Akure, and then confirm and save. So this, because this is Akure course, we can just save this as PDA course, OTIC Akure, and then we'll click on OK. So anytime we want to connect to Akure course, we just select the Akure course and then we'll click on start. So we've connected to the call station. See, now we have a float signal because the call station is not close to where we are. It will take time to fix, or it might not even fix. So let's connect again. Let's set up another course parameters. This time we are using our OTIC Aja call station. So we are still using PDA course. Our protocol is still going to be course. Now we now enter the IP address for the call station. Just give me a minute. I'm trying to reconnect the app. So sorry for the break in transmission. So we are back on. So I saw a few questions while we were trying to reconnect. So I will just so Atabo said, how can we get the Survey Master software on our device? Okay, so you see this Survey Master version that I'm using currently is version 4.0.2. If you are going to use this Survey Master version on your phone, you have to pay for a subscription. That is software subscription. Now, there are other versions that you can use on your device. I think as from version 3.4 downwards, you can use 3.4 without subscription on your phone. But for recent versions, you have to pay for subscription. So we will upload a link to where you can get the software on our drive. So it will be uploaded on this on the webinar, I think on the evening session. So just if you can stay with us, you get the software. So that's how you can get the software for your phone. Also, the one you have on your data logger, you can also send it to your phone as well. But the only thing is, if it's a recent version, you have to pay for subscription. So that's how to get the application on your device, on your phone. Okay, so also somebody asked on how that we should talk about the internal the rover setup again. So we are going back to rover setup. So on rover, I mentioned that on base station, on the base setup, you can send the corrections through the internet, which is internal GSM. You can also send it through radio, the internal radio, and then the external radio. Now, for rover, let's say we want to create a new work mode. If you are sending your correction through GSM on your base, you can receive it on your rover with PDA course or with internal GSM. The two of them is still through the internet. The only difference is that on the internal GSM, the network is coming from the SIM card on the receiver, while on the PDA course, the network is coming from your data logger. So you can share your hotspot to your data logger, or you can also put your SIM card on your data logger. So you can use either of the two to get your correction from your base through the internet using any of these two modes, so the PDA course or the internal GSM. Also, you can also use your PDA course to get correction from the call station. The call station streams with the internet. So you can also use either the PDA course to get correction from your call station, as well you can use the internal GSM to get corrections from your call station. Now, on the base, you see there's no external, on the rover, there is no external radio because you can't be carrying battery and external radio and long antenna with your rover while you are doing your site work. So if you are using internal radio or external radio on your base, the rover is just internal radio because it's still that same small whip antenna that will be receiving the signal, whether it is internal for the base or external for the base. So whichever mode you are using on your base, you have a mode on the rover that will accept it as well. So if you are using the internal radio mode, like I said, based on the setup you do on the base, which is your protocol, and the channel you are using to communicate, you also have to do that on the base as well, on the rover as well. Now, if you are using the PDA course, we've not connected to our receiver, so let's quickly connect. Okay, now we've connected to the receiver. So when we go back to our rover setup and click on new, so I mentioned that if you are connecting whether with internal or external radio from your base, the rover is just internal radio. The same way, if you are connecting to your base using internal GSM on your base, or you are connecting to a call station, you can use PDA calls or internal GSM for your rover. So let's say for a start, let's select on a PDA course, and then we'll select our call station protocol. You see, it's still asking us for IP address, port number, username, and password. The same thing, if we change to Eternal GSM and still select our protocol as call station, it's still going to ask us for IP address, port number, username, and password. So it's the same thing. As long as you are getting the correction through the internet, you can use GSM or PDA calls. So we wanted to connect to our AJA course before the receiver went off. So now that we are using, we are still going to make use of PDA calls because we don't have SIM card on our receiver. We type in the IP address for our AJA course as 18.168.2.71. Then the port number is 3717. The username is, I'm not going to tell you the password. Now, when you do that, you also need to generate the source list. When you generate the source list, you now select from the list of call stations you have. So currently we are close to AJA, so we can just select AJA. If you are close to Songo course, you can select Songo. If you are close to Ekpe course, you can select Ekpe. And of recent, we've installed another call station in Badagry. So if you are close to Badagry as this, you select Badagry course. So now we are using AJA course. You click on confirm, and then we save. So we are saving this as PDA course, OTIC, AJA, and then we click on OK. It has been added to the list. So, I mentioned that these ones are recurring settings. Although we've already saved the setup on our Survey Master, what we just need to be doing as time goes on is to select the one we want to use and then apply or click on start. So we are selecting OTIC AJA now, and then we click on start. It will configure and then connect to that call station that we've configured. See, now we've connected to AJA course and it's about to fix. Now you see this warning base change that comes up. It comes up anytime you've connected to one base and then you are connecting to another base. So it's just to give you an information of your current base station, your previous base station, and then the change in the distance. So before we use accurate course, and accurate course from where we are is about 200 kilometers from us. So if you see the change in distance is 201. So if you are okay with this setup, you just click on OK, and you see our call station is fixed. So that is how to do your base and rover setup, and also how to configure your call station. Another thing is there are some call stations that you might want to connect to, although not SinoGNSS course, but there are some call stations that you want to connect to after entering this let's say we are using PDA course and then we are entering a call station. After entering the course parameters, which is the IP address, the port, you cannot generate source lists. Those call stations does not have the power to generate source lists. So what you do is you need to type in the name of the mount point manually. It's still going to work. So the only thing is that it will not generate the list of call stations for you. So if you are connected to that kind of course, just type in the name of the mount point. So let's say you are using OTIC AJA now, you need to type in OTIC AJA manually on this mount point. So you need to type in OTIC AJA manually on this mount point and then click on confirm and save and apply. It's still going to work. But for other ones that you can generate the source list, you just quickly click on the download and then you select from the list and select the call station you want to make use of. So basically that's all for setting up your call station or connecting your base and your rover. And basically that's all for setting up your work mode. Now, Another thing we are going to talk about is how to do your survey after you've set up your work mode. So let's connect back to our JACOS. See, it's fixed. Now we go to topo survey. Now these are topo survey page. So if you want to pick a point, you see the blue icon by the right side, almost at the bottom of the screen, is your survey icon. Now our occupation time is at 1 second. So if I say survey, it will just count for 1 second and then it will give me the coordinate of that point. Another thing is, we talked about topo settings. So you can also access your topo settings on the left side of the screen. If you see fixed under yours or on the left side, you see D1. Under D1, you see settings. So you just click on that settings. It will still bring you back to these settings that we did initially. Here we set up our HRMS, our VRMS, and also our, if you want to get duplicate name and all that, you see them here. Also, we talked about information. Now, if you look on the bottom part of your topo survey screen, you see your northern coordinate, your eastern coordinates, distance to base, your Z coordinate, and also change in height. Now, if you remember, we turned off change in 2D. So if you want to bring that back, you come back to settings, you click on information. See, this is our change in 2D here. We are adding it to the screen already, and then when we go back, see change in 2D is now showing on the topo survey page. If you want all those information, all of them to show, when we come to information, just to click on this and be adding them one after the other. Well, you see the ones that we've added, the D and the L is now showing under the screen. So that's how you add and remove information from the topo survey page. Finally, also, we'll still talk about how to do setting out of points. So if you want to set out a point, you see stake point on the screen. Click on stake points. From here, if you look under the screen, you see lists. So just click on that list. Sorry, not the list, the icon next to the list. It will bring you to your element page where you can just select the coordinate that you want to set out, and then you click on this green icon. It will now start showing you the direction to the points and then the distance in 2D. So this is how you do setting out. We also talked about doing calculations like calculating your area, calculating earthwork, calculating coordinate geometry, and so on and so forth. So they are not difficult to use. For area calculation, you need to select the points, maybe 4, minimum 3 points you want to use to calculate your area, and then you do compute, it will give you the area. So if you want to add the point, you see add at the middle under the screen, click on add. Go to your elements and then select the points you are using. And then click on confirm. You can come to preview. Preview will show you the shape of the area you've selected. And when you go back, you can now click on compute. So this is your area, 0.711 square meters. So that's how to calculate your area. If you want to measure a distance, you come to Kobo, which is coordinate geometry, you select 2 points. From your point 1, you can go to element and select, let's say we select 1, and then we click on confirm. For our point 2, we also go back to element and select OTS1, and then click on confirm. So see the azimuth, which is the forward bearing from point 1 to OTS1, and then the horizontal distance is 1.4. So that's how to calculate distance from your survey master application. Now, one important part of your using the Survey Master application is that when you go to site, you need to export your data. That means all the things that you've been doing in sites, you need to bring out those data. Now, to do that, which is to export your data, you come back to your project page and you click on export. And when you click on export, there are various and different formats that you can use to export. You can export to a DAT file. You can export to Excel. You can export to text, which is a notepad. You can export to DXF. You can export to DWG. You can even export to PDF direct. So for now, we are just going to stick with Excel. So if you select name NEZ, meaning you want your Excel file to carry the point ID, the northings, the eastern, and the Z coordinates. So you click on that, and then you click on next. So what you want to export your survey points. If you want to export your calculated points, your control, your base, your map point, your unstake point, your input point, any point you want to export, you select, you check them in. But for now, you see we are exporting only our survey points. So that's checked already, and then we'll click on next. It will now ask us to save the file. So saving it converts those points coordinates to your Excel file, which you can later transfer to your system for other uses that you have them for. Also, you can do export direct to DXF or even DWG. So let's say you are doing to DXF, you select DXF, go to the next. Also, you need to select what you are expecting. So we'll select survey points. If you are exporting your base coordinates, if you are exporting your control points, whatever you want to export, you just tick them. Now this text size is 0.5 and your decimal is to 1 decimal point. So click on next and then click on export to save the file. Afterwards, you can transfer to your laptop or to any other device you want to use to process. So these are basically what you can use your Survey Master application for: creating your work modes, creating your coordinate system, doing exports, taking points, and also taking out of points. There are lots more. Just if you can just go through the application, you see other features that you can carry out, other functions that you can carry out using the Survey Master application while connected to your GNSS receiver. So thank you very much for staying with us. Also, you can drop your questions afterwards. We'll attend to them. So that's all I have for you for today. So thank you very much, and then hope to see you another time.
Thank you so much, Edwin. Thank you for that insightful session, for the hands-on. So thank you. So please, if you have questions on this session, please just drop them in the chat box. So we'll quickly go to the next one, which is troubleshooting common field issues, and how to properly care for your equipment. So for that session, I'll be inviting my colleague as well, Mr. Kenneth Emmanuel, to handle that session. So Mr. Kenneth, you're on now. Please, if you have questions, drop it in the question and answer session, and then, or you can put it down in the chat box, either the question and answer box or chat box. Okay, Mr. Kenneth.
Afternoon. Can you hear me? Good afternoon, everyone.
Yes, we can hear you.
Hello?
We can hear you.
Okay, good afternoon, everyone.
Yes.
I want to once again welcome you to today's webinar. This session is on troubleshooting common GNSS field issues. Before I start, I want to ask you a question. Can you raise your hand up if you've ever experienced when you are in field, and your instrument refused to fix? Your instrument refused to fix is just like single or just like float for like 10 minutes, and your client is just asking you, Alpha, what's happening? What's going on? Some clients are very impatient. Based on if you've ever experienced something like that. Okay, so I don't know if you can see my slide. I don't know if you can see my slide. Please, if you can see my slide, let me know so that I can move on. Okay, thank you. Thank you. So sometimes we have a situation whereby you go to sites and that day you realize your village people followed you to that site, like nothing will want to work. You apply fix, you apply based on over internal radio to not fix, you apply course to not fix. So today we want to deal with some of those issues we usually face on fields, on sites. So we want to talk about them, and then we can now look at how you can solve those issues. So we are going to start with accuracy can't meet demand. So what is accuracy can't meet demand? So if you look at this screenshot, you will see just below the screen of the image, you see on this area, accuracy can meet demand. Please check. Can you see it? Accuracy can't meet demand. Please check. Just below that icon that is like location where you pick points. Above the box, accuracy can't meet demand. Please check. So many people they have experienced this on site, and they become frustrated. They feel like maybe it's the network or the receiver is refusing to communicate with the base, or the receiver has refused to work for them that day. The receiver is on leave. The receiver doesn't want to. The receiver is protesting. Doesn't want it to be somewhere to work. So what really causes this accuracy can't meet demand? It is when you set your accuracy to be at a certain point or a certain level or at a certain value rather, and you try to pick a point when, due to atmospheric, ionospheric, and some other conditions, your signal was not strong enough to give you that particular accuracy that you set for that project or that you set for your device. Now, if you look up at the top right of this screenshot, the screen, let me say it's a screen, the top right, you will see something called H, and you see it at 0.003. And you will see something called V, you see it as 0.004. Those figures are like your accuracy benchmark, like your accuracy values that your GNSS is using to give you coordinates. So it's telling you that due to the best I can compute for myself through the correction I receive from wherever your correction is coming from, whether from base or from cost or from whichever entry, or you understand. This is the best value I can give you per accuracy. So your horizontal, I can only give you this 3 millimeter accuracy because I have calculated it to the best of my ability. I have calculated it through, after removing all the corrections, after removing all the I've used my algorithm to remove some errors and all that. I can give you for the V 4 millimeters. So, but in your own setting, you place the accuracy. Let's say you place the accuracy to be below, to be 0.001, which is 1 mm, or 0.002, which is 2 mm. When it is on that value as your to set accuracy that you need for your job, you will not be able to pick a point because your GNSS will be telling you that your value is below the accuracy that you told me to give you. What do you need to do is just to come to this HRMS and change it to increase the value. Increase the value, you can increase it to maybe 0.03, you can increase it to 0.1. So it just depends on the accuracy that your job demands. If your job, the job you are doing demands a very high accuracy, you have to set it to that level. So this is how you solve accuracy can't meet demand. So if you put it to 0.01 and you click OK. OK is below, when that's down, when you scroll down to the last option, you can see it on the screen. OK is in blue. Now it will take you back to the topo survey page. The topo survey page, you will then be able to pick points, to allow you to pick points, because the accuracy you set for your GNSS device is now higher than, is now lower than what the GNSS is computing. So the GNSS will be able to work with you. So most people usually they have usually frustrated. They'll be like, today these GNSS are just be because that's the beeping it makes when it's telling you accuracy can't meet demand. So this is how to solve accuracy can't meet demand issue. So software and configuration. So sometimes when you go to site, you might find out that your device is saying something like, this device has expired. This device has expired. So most times what happens is that your device is on a temporal code, temporal access code. This is due to some factors, you know. Some people, their device are on temporal access code. So whenever your device is saying your device is temporal has expired, it means that you need to request for an access code so that it will stop blocking access to signal. Because when your device is temporal, when your device is expired, your device cannot fix, your GNSS cannot fix, you can't work, you can't do anything. So when you request for a code, it will be given to you. All you just need to do is go to this register. Register is by the second line by the right under base. So you click it. When you click it, you type in the digits, the figures that was given to you, together with the hyphen. So a set of figures will be given to you, with each of them separated by an hyphen. So type in the figures and the hyphen, and then you click register. So once you click register, your device will ask you, do you want to reset? You click reset. It is going to restart your device, and then you'll be able to now be able to work. All you just need to do is, most times it can still be on single. Just go back to your rover and reapply. So sometimes it's that maybe you are applying the wrong setup. I've had a situation whereby somebody use receiver to set up as base and did not disconnect from the base. You know, when you set up your base, it's going to tell you your base setup has been set up successfully. Do you want to disconnect and connect to your rover? Some people will say yes, they will disconnect from the base. So it will bring you to this connection page where you will then go and look for the serial number of your rover. But some people will forget and we connect the base back as the rover which they are supposed to connect as a rover. They will connect the serial number, the receiver of the base again, and then go to rover and then apply internal radio. So they are now setting up the base as a rover too. So they're now setting up one device as base and rover. And in a situation like that, they'll be disturbing and they'll be calling, this receiver is not working, what is happening? I cannot, it's just single things. And then when you check, you see that you ask them, what's your receiver, your base serial number? You see that it's the same thing with the one that I'm using as a rover. So when you do something like that, your receiver will refuse to fix, because the base work mode is a very powerful function. When you are using a receiver as a base, it dies faster than when you are using it as a rover, because the base is a very powerful function. The transmitting signal is more powerful than the receiving signal. So when you are using a receiver as a base, it becomes a transmitting signal. The radio or the whatever it's using to send becomes transmitting, TX. But when you are using a receiver as a rover, it becomes receiving signal, RX. So the base is a very powerful function. So when you use the receiver as a base and you want to use it as a rover, it will not fix. It will not allow you to work. It will not allow you to work. Why? Because work mode, they have a very slim difference. So what do you do in such situation? What you need to do is to reset it, is to factory reset it, F reset. So how do you factory reset it? You go to this device info, under connection, you see device info. When you click it, you go scroll down, the last option where you see preset, you see it restart. Some version of SinoGNSS Survey Master, we say that it's F reset and reset. So when you click it in this restart side, in this restart arrow that is greater than, It will take you to this second page where you have reset in white and reset in red. Click the red one, which is reset. Click the red one, reset. So it will ask you, are you sure to restore factory? You say okay. When you say okay, the device is going to restart. This is a situation where you are having situation where you use your base. You use a receiver as a base and you want to use it as a rover. Or you mistakenly use the rover as a base. You know, it will not allow you, it will not allow it to work. So you have to reset it. You have to reset it. So that's for when you have software, you have configurations. So sometimes we have situation where we have hardware issues. It may be that your cables are bad. That's why maybe your external radio is not working. Your battery is bad. That's why your device is not coming on the sites. So you have to make sure that you check those stuff properly when you are having all those difficulties, because hardware issues, sometimes your mind will not even go to that you have a hardware issue. Your mind will not go, because hardware problem is not easily identifiable. Your mind will just be like, this thing is not working. This GNSS is not working for me. Meanwhile, it might be that you didn't put antenna, with antenna. You have situation where some people will not put with antenna when they are using base and rover. When you are using base and rover, you are using it in internal radio mode or external radio mode. You have to ensure that you put your whip antenna for internal radio mode. The whip antenna will be in the base and the rover. For external radio mode, it will only be in the rover for the whip antenna. You have the long external radio antenna for the base. So if you forget to put your antenna, you do not put it on your rover or on your base, you might have situation where it will fix. It will fix. But when you move further you move away, you take your rover away from your base, it floats and then it singles. You come back, it will fix back. Yes, because it has internal, but the whip antenna acts as a booster. The whip antenna acts as a booster. It boosts the frequency of the internal radio. If you are using internal radio, it boosts it to a longer distance so that you can work without a line of sight. So we also have, when you put, for these hardware problems, when you put your GNSS, when you set up your GNSS where there is no clear view of the sky, where you put it where there is no clear view of the sky, is an hardware problem, because the receiver is an hardware. Maybe you put it under a tree or you put it close to the wall. No, they say SinoGNSS physics under canopy. So set it anywhere. Just put it under tree. Put it under a tree. No, it's not a good way to set up your GNSS for work. Not a good setup work mode. Always make sure that where you set your base should be where there is clear sky view. Like, because once there is the sky is clear, the GNSS can see a whole, let's just say, 280 by 250 sky. There's something called max angle. If your GNSS can see the clear sky very well, it will not affect your mass angle. So mass angle, what is mass angle? Mass angle is like the angle which the receiver is set to work with a satellite. So if the receiver is set up at 15 degree or 10 degrees, SinoGNSS is 10 degrees. If a receiver, a satellite rather, in the sky should cross that angle, that should pass it, maybe the angle is on a certain plane and it goes below it, it will write it off that I'm no longer going to be using that satellite because it has passed where I can calculate some certain errors out. The error that is going to give me that angle is going to be high, and it's going to affect the work my user is going to do. So that mass angle is going to be very, very optimized when your receiver is, your GNSS antenna is having a clear sky view. Also, your battery life is an hardware problem because some people don't take proper care of their battery. The battery might start up as 48 hours, 24 hours, 12 hours usage, but due to their overcharging, overnight charging, long charging, it will have full, but they will still leave it plugged in. The battery life becomes lesser, and some people don't know the battery life of they are working with. So let's say, for example, now your battery life is 12 hours, and you've used the receiver for 6 hours today. Use it 3 hours. You'll be like, they say it's 12 hours now. I only use it half. On the next day, you are now going 15 kilometers walk. Your GNSS is going to die along in the middle of your walk. So your battery life limitations during long surveys, you should always put it into consideration. It's an hardware problem. So your data collector also, your data collector connectivity problem. Some data collector, some people allow their data collector to fall, some people just plug it in anywhere. When your data collector start having issue, it's going to be problem for you. So always use recommended data collector, that's data logger. Always use recommended data logger. Take care of it very well. Ensure that you don't just plug it anywhere now, so that virus that's not disturb you during site work. So that's for your hardware. So we have external interference. So what are the external interference that can disturb you during site? Multi-part and physical blockages. So in the external interference, what's multi-part? Multi-part is where you have a situation whereby the GNSS signal is being bounced up multiple times before it gets to you. So it's not a straight line. And the GNSS kind of have a way of calculating the signals they receive from this satellite. So when you have tall buildings beside you, you have shiny or objects, maybe mirrors and all that, it gives your GNSS issues. You'll be having situation where you'll be having float, single, fix. fix, float, fix, float. So when you're having such kind of situation, you now have to ask yourself, is GNSS the best equipment to use in such sites? Or should I employ the use of laser or the use of total station? So that is one of the one of the issues some people face on site. They go to where there's total buildings and they're having fixed flows. It will give them a lot of issues. Some people will do like they want to work despite the fact that it's having float, that's giving them float. They want to work, so they go to settings. They go to settings, and then in this fix, they toggle it off, and say okay. When you toggle it off, it allows you to work. It allows you to pick when it's even if it's not fixed, because you've set up a criteria. You've cancelled the criteria for it to pick on fix only. So now when there's float, when there's single, it's going to allow you to pick. But ask yourself, will you be picking in the best situation possible? If no, always do the right thing. So we have situation whereby there is GNSS jamming, where there is a radio frequency interference, there's nearby equipment, somebody else's equipment is also using the same radio frequency and protocol as them. That's when it brings up that situation of base change. Because some people, for example, now SinoGNSS default channel is channel 6. You can go to a site and you are working on the right hand side. Let's say you are working on Chevy View, and then there is a surveyor that is working on Chevron just opposite your own site, and he's using channel 6 too. If you go out of range of your own and go into his own range, your GNSS might single your float and then fix on his own. That's why you have situation where you say base change. Am I communicating to somebody? So you have situation like that where you just hear your base has changed. Then to not give you the coordinate of the new base. So, but the downside of that is that some people don't properly set up their own equipment. They don't properly set up it's not everybody that do the right thing site. You may be doing the right thing, you might have put it on the correct coordinated beacon, but the surveyor your equipment as connected to might not be doing the right thing. You might just be doing a quick job, like working on auto base. I've gone to a land allocation site, and the surveyor there setting up on the allocating the land was allocating the lands with auto base. When I picked the point, because it was land confirmation and area confirmation. When I picked the point, there was discrepancy in the coordinate system, in the coordinates. I met the surveyor. He said, "It's correct, it's correct." I said, "No, surveyor, look at what survey plan and look at what was set up. So later, after much, he was trying to tell me, no, not like that. After much, he not tell me that he just set up as auto base because he just want to rush and put the setup because then he will come back and use fix and use fixed point. That's a coordinated point, and we allocate the land. But meanwhile, those clients want to start doing their rafts. Immediately you are allocating them. Many of them are already start paying for block and cement and manual labor to start doing their raft. So not everybody does the right thing. So ensure that when you're always conscious when your device say base change and it gives you a new coordinate system. Just know that somebody else is in the vicinity that your device has connected to, and you might not be sure the person is doing the right thing. So radio frequency interference from nearby equipment, jamming using radio frequency to disrupt channels, signals, GNSS jamming and spoofing, because as time goes on, even consumer grade GNSS have become more prevalent. So GNSS signals will be more rampant. Also, we have electromagnetic interference. You can have a situation whereby you are under, maybe you are surveying and you are going close to power line. When you are close to power line, it's going to give you issues sometimes, especially if it's those high voltage, those very big transmission lines, those 33 kVA upwards. Even the smaller ones will also give you interference issue. When you are doing survey where there is a lot of metals, like in a plant environment where it's plant pipes and all that, iron pipes and all that, you might have electromagnetic interference, unless your GNSS is of the high grades, the most recent ones, like our SinoGNSS, the ones with K8 boards. Those ones have electromagnetic interference correction built into them. So when you are working in plant environment, take note of it. Sometimes your GNSS, if your GNSS is of a low grade, if you are not using Sino, your GNSS can be telling you magnetic interference. Just know that. Okay, so RTK fix problem. So sometimes we have situation whereby you might be having fixed float. Most times it might be that your receiver is not properly set up. Or your internet is not, if you are using a course, your internet is not strong. Sometimes it might be your environment. If your receiver is not the one that can work on that canopy, it will be having that kind of issues. Sometimes your base station might be having low battery. Your base station might be having low battery. So it will be giving you fixed float. So this is how to tackle your fix with RTK fix problem. Just check the mode you are working with, check the environment, ensure you're working in environment that GNSS can work in. Check that your base communication is stable. If your base communication is stable, remember not putting antenna, low battery, your base station that has fallen before and something inside has broken to be giving you those issues. So when your receiver is having a long time to fix, it might be firmware issue. When your receiver it always takes like 3 minutes, 4 minutes, 5 minutes before it's fixed. Every time you turn it on and try to connect to maybe course or your base, it will take 5 minutes before it's fixed. In your firmware, it might be the firmware is an old one, or there are different types of firmware. It depends on what you want it to do. Like for example, the PPP firmware is the one that makes a rover to take a long time before it fixes, because PPP firmware concentrates on precision rather than range. So when you have the PPP firmware enabled in your device, you take a long time before you usually get fixed. So, but the normal GNSS firmware, they are good, they fix it, they take 10 seconds, 5 seconds before they fix. So if your device is having issue of fixing, just go and do device info F reset, because it might be that your device has been stuck in base setup. So RTK fix might solve most of your problem. So that's it for troubleshooting. So let's discuss how to properly take care of your receiver, your equipment. So always set your receiver on a stable and secure surface. Always put it up where it will not fall, where it will not be shaped. While it can work in various weather, do not use during heavy rain. In light shower, use a shower cap for receiver and ziplock for data logger. Use shower cap for receiver, use ziplock for data logger. So that rain, yes, we say the receiver is IP68. Yeah, it doesn't mean you should allow it to soak inside water. Doesn't mean you should, it's waterproof. Doesn't mean you should not throw it inside river. No, protect your equipment, because nothing in this life is guaranteed. If water contacts the receiver or cables, wipe and dry thoroughly before storing. Never twist or rotate the lemon port cable. The lemon port cables are the 7-pin and the 5-pin. 7-pin for SinoGNSS, 5-pin for other receivers. So this is very important, because it might give you that fixed float issue. Always connect the cables to receiver or external radio by matching red to red. So red to red, there is on your lemon cable, you will see red close to the 7-pin or close to the 2-pin, depends on or the 5-pin, depends on the type of cable you are using. You will see a red dot. So when you are putting it inside the receiver or the external radio device, ensure that the red is going to meet the red counterpart in the other device. If not, your pin will break, your device will become damaged, your cable will become damaged. So use only approved accessories, including batteries, chargers, and cables. Unapproved accessories may damage. Always transport in the supplied hard case with foam padding. Always use that case. Some people will put it inside the bag for convenience. But what if that bag should hit a wall? That device will break or become damaged inside, and you will not know. Better you blaming the equipment. Do not charge data logger overnight. Only use approved chargers. Don't plug in your charger and sleep. Plug it when you are conscious and awake. Don't overcharge it. It will damage the battery life. For the battery, how to take care of the battery? Always use the SinoGNSS supply charger for battery safety. Do not use or charge damaged batteries. If your battery is showing sign of coloring, decoloration, is showing sign of swelling, is leaking, kind of acidic something, all this acidic, don't charge it. That battery is damaged. Replace it. Do not charge batteries overnight. Never immerse batteries in water to cause it to become damaged, because these are solution. It will form a solution that will damage your battery. Do not store or use battery inside hot vehicles. When you put your battery or use it inside hot vehicle, it will cause a chemical reaction in the battery that will cause the battery to swell up and like burst. Battery might, you understand. So don't put it inside hot vehicles. Fully charge new batteries before first use. This is to preserve the battery life. Before you use it first, you charge it fully. If storing the receiver for a long time, remove the batteries. If you are not going to use it for a long time, maybe you want to travel out for a long time, you will not be away, you will not be around, charge it at least to 80% before you remove the battery and you keep it. Always store battery in dry condition. Remove batteries before shipping the equipment. If you want to send the equipment through cargo and all that, remove the batteries, keep it, store it in a way that to protect the environment, both the vehicle and everything around it. Wrap it properly, because in tight situation, in tight pressure, in pressured confinement, the battery may explode, it might catch fire. Not charge data logger overnight. Use only approved chargers. So discuss this. So receiver location tips. Choose a site with a clear sky view. Avoid tall buildings. Whenever you want to work with in an area.
Mr. Kenneth, we can't hear you.
Sorry, so I'm just rounding up. So, sorry for the broken transmission. I'm at receiver location tips. Just choose clear sky view when setting up. Avoid tall buildings. Don't, anytime you have a tall building site, data station, or laser GNSS, keep the area free of obstruction and traffic. So I hope I'll be able to pass some. I hope I'll be able to pass some problem solving tips to you. Thank you very much. See you in the evening session to discuss more.
Common field issues, and then how to properly care for our equipment. So let's quickly go to the questions. So the first question we have here is most of the 7 parameters value not the same with respect to different locations, but get from site calibration on the existing control points of the area. So I don't know if it's asking a question or it's making a statement. So Mr. Kenneth or Mr. Edwin, you can say something on that. This is by Mr. Sunday. He's saying most of the 7 parameters value are not the same with respect to different locations, but the best accurate value is to get from site calibration on the existing control point of the area. I think he's referring to when Mr. Edwin was inputting the 7 parameters for lag vector 4. So lag vector 4 is a customized coordinate system for surveyors here in Lagos. So you can also customize coordinate system to suit your location. So you can't use the custom coordinate system for a particular location, for a particular site, and then apply it to another site. So that's why it's called custom. So someone else asks, Mr. Sunday asks, for the SIM card mode, where do we insert the SIM card? Data logger or receiver? Mr. Kenneth, you can answer.
Okay, for the internal GSM, you put the SIM card in your GNSS receiver. In your GNSS receiver, you have where there is a SIM card slot. You have a SIM card slot. I'm coming.
Okay. So we have SIM card slot, data log, and also the receiver. So you can choose where to insert your SIM card. So someone is asking, how much is the subscription for the new Survey Master app version? How much is the subscription for the new Survey Master app version 4.02? Edwin?
So please, also, you can also put SIM card inside your data logger. And you can also share data through hotspot to your data logger. So if you are using SIM card in your data logger, it's going to become a cost. If you are sharing hotspot to your data logger, it is PDA cost also. PDA cost is referring to an external internet aside from putting a SIM card inside your GNSS device. So when you put SIM card inside your GNSS, it is internal GNSS you will use as the work mode. So SIM card inside the GNSS receiver is an internal GNSS. SIM card inside the data logger is PDA cost. Hotspot shared to your data logger, PDA cost also. Thank you.
Akiwande Edun will expand on the PPP mode in the evening session that will be starting by 4. So we'll talk about that, the PPP mode. So the next question is from Ibrahim. He said he couldn't get how to apply internal radio setup for rover. So Edwin, can you say something on it? I couldn't get how to apply internal radio for rover.
Okay, good evening. So if you're trying to use your GNSS receivers, which is your base and your rover, with internal radio. Sorry, you said internal radio or internal GSM?
Internal radio.
Okay, so if you are trying to use your GNSS receiver on internal radio mode, you have to set up the work mode on the base and the rover to be the same. Now, if you check, I just want to share my screen again. So please confirm if you can see my screen.
Yes, we can see your screen.
Okay, so I just want to quickly rush it now. If you come to device and you go to base and you click on new, or okay, yes, you click on new, and then you are now going to select your data link. So data link is the mode of communication between the base and the rover. So if you select your data link as internal radio, it will ask you to enter the parameters of the internal radio setup. So what you need to set basically is the protocol, which is the command it will be sending, and then the channel it will be sending that command through. So once you select your command for transparent, and then the channel is channel 6, you can confirm this, and then you select your start mode either in a fixed position or auto base, and then you click on save. Now the same setup we've done on the base is the same setup we are going to do on the rover when we click on rover. Click on rover. And then we click on new, and then select the same data link, which is internal radio. And then if you check, you see the same settings that we saw on the base is the same thing showing on the rover. So once you have the same setup, your base and your rover should communicate once you apply this setup on the base and the rover. So that's how to set up your work mode using internal radio. Thank you very much.
Thank you, Edwin. Malik is asking if there's a way of tracking your GNSS. Let's say it was stolen, since it's a tracking device itself. It's asking the way to track your GNSS receiver. Mr. Kenneth. Mr. Kenneth. Mr. Kenneth, please help answer that question. Malik is asking if there's a way to track his GNSS receiver if it was stolen.
For now, there's no way to track your GNSS receiver if it is stolen or if it was stolen, because they have not found a way to implement tracking inside the receiver itself, or a tracker rather. So the only way you can do it, maybe if you attach this iPhone port that is used for tracking things, it's used for locating your stuff, maybe your iPhone port or your phone. So, but GNSS itself, there's no way you can track your stolen device. So ensure that you put somebody at base to watch it, and be very careful, especially when you go for disputes or sites that are in disputes. Ensure that maybe this device is GNSS that you can carry and run, that you use and go to that site, so that when the problem starts, you can easily carry your equipment and run. so that you can track it normally.
Do we have any more questions? I think Edwin has covered the part for internal radio and rover. Someone is asking, how can we get the Survey Master software on our device? Edwin?
Okay, we are uploading all the softwares, the different virtuals on our Google Drive. So the link will be available in the evening session. So just when you come for the evening session, you get the link for all the different Survey Master versions.
Okay. Thank you. Please, do we have any more questions? You can raise your hand so I can unmute you. I can grant you permission to talk if you want to speak. Any question? Okay, in the absence of that, I want to say a very big thank you to our participants today, you that took time to attend this webinar, to ask your questions, to engage with us. We don't take it for granted, and we are glad that you stayed till this time. I know you've learned one or two things that you're going to apply in your project. So this webinar will still be continuing in the evening. So if you have time, please make room to join us again in the evening. It also give you time to know questions that you can address whatever concerns you may have. I also want to remind you of the complete surveillance training that will be happening this August from the 28th to the 29th of August here in our office at Chevy View Estate along Lekki Expressway. So the training is basically about the construction applications of total station levels and GNSS equipment. So it's not a training that you want to miss, especially if you have been intending to penetrate the construction industry. So please don't miss it. It is value packed. It is centered on adding, on elevating your skills, on making you, on distinguishing you in the surveying profession, the surveying field. So please don't miss it. The link is in the chat box. So click the link. And thank you once again for joining us. Thank you, thank you, thank you. So I'm hoping to see you in the evening session. Thank you to our facilitators. Thank you to our speakers. Thank you for the insights you've shared. We are grateful and we've learned a lot. So thank you and see you again this evening. Bye for now.